Assalamu alaikum students. Today we are going to discuss characteristics of wave parameters. So these characteristics include wavelength, frequency, amplitude, time period and wave speed. So we are going to discuss it one by one. First we are going to discuss wavelength. Wavelength is the distance between two consecutive wave crust or trough. Okay, you know that a wave consists of a crust or trough. Okay, so when we are calculating or we are finding the distance between two consecutive crust or trough, so that is the wavelength. ओके यानी एक दूसरे के बाद जो लगातार क्रस्ट आ रहे हैं उन दोनों के बीच में डिस्टेंस इज वेवलेंथ, और या एक दूसरे के बीच लगातार जो ट्रफ आ रहे हैं उन दोनों के बीच में डिस्टेंस, इट इज़ अ वेवलेंथ. ओके, now in the following diagram I show you that it consists of a trough and a crust and a trough. Okay, and the distance between them is the wavelength. If you look at this diagram, so the upper one area is the crust and the lower one is the trough. So the distance between two consecutive crust means एक crust और इसके बाद दूसरा crust जो आ रहा है, इन दोनों के बीच में distance या एक trough और दूसरे trough के बीच में distance, that is the wavelength. Or we may say that like this, that one crust and one trough, it makes wavelength. Okay, now we are going to discuss frequency. Frequency is equals to the number of waves that passes through a given point per second. Mean in 1 second how many waves passes through through any point. Okay, suppose we take a point A, so we want to find that how many waves pass through that point A in 1 second. So if suppose one wave passes, so frequency will be 1 hertz, and if two waves passes, so frequency will be 2 hertz. Okay, and the unit of frequency is hertz. Look, I also show the unit here, that hertz is the unit of frequency. Now we are going to discuss amplitude. Amplitude is the measure of how big the wave is. Means the distance from the mean position to the maximum height, to the crust, to the maximum crust or to the maximum trough, both. That is the amplitude. Means when we want to check that how much is the height of the wave or how big is the wave, so that is actually the amplitude, that we want to check it, that the height of the amplitude from the equilibrium position is how much. Okay, now we will discuss time period. Time period is the time it takes a wave to complete one cycle. Now in time period we are actually finding time, and we know the number of cycle, that is one cycle. So in how much time one cycle passes through a point. फ्रीक्वेंसी में हम क्या कह रहे थे कि हमें फ्रीक्वेंसी में टाइम का पता था 1 सेकेंड, 1 सेकेंड में कितने वेव्स पास हो रहे, और टाइम पीरियड में हमें टाइम का नहीं पता और वेव का पता है कि 1 वेव इज पासिंग. सो इन हाउ मच टाइम 1 वेव विल पास थ्रू अ पॉइंट, सो दैट इज द टाइम पीरियड, and it is denoted by a capital T. Now we are going to discuss wave cycle or wave speed. Wave cycle is simply the cycle of the wave, that it is consists of a crust and trough, and it passes in a form of a cycle. And wave speed is the speed, the distance traveled by a given point on the wave. Okay, means how much distance a wave travel in a given time. You know that speed is denoted by v. V is equals to distance by time, that is s by t. Now in this case, in the case of wave, this distance is the lambda, wavelength, and t is the time period. So we will put this value in equation 1. So it will become v is equals to lambda by t. Now we know that frequency is equals to 1 by time period. Frequency and time period are inversely proportional to each other. So put equation 3 in equation 1, we will get v is equals to f lambda. This is the relation between speed, wavelength and lambda. इसका मतलब ये है कि speed of the wave will be more when the frequency is more and when the lambda is more. Here I am going to show you some video. So with the help of this video, it will be more clear to you that what are these all terms.
Hey Bubbles, look at these sea waves. Have you ever wondered how high these waves are? Or how long is one wave? What about the speed of these sea waves? But first, how do we define waves?
Excellent questions. Waves transfer energy from one place to another in a medium through a series of disturbances or vibrations that carry energy. Here are the basic features of waves: amplitude, wavelength, frequency, speed. These four quantities describe different properties of waves. Let's discover what each of these mean. First, let us look at amplitude. As waves travel, they create disturbance. The amplitude of a wave is the maximum distance of a wave's crest or a trough from its undisturbed or rest position. Think of a calm sea and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea level.
So, is amplitude the distance between a crest and a trough?
No, it is the distance of either the crest to the rest position or the trough to the rest position. Therefore, the vertical distance between a crest and a trough is in fact equal to two amplitudes.
Oh!
The amplitude of a wave is measured in meter, m. Next, let us discuss wavelengths. A wavelength is the distance between a point on one wave and the same point on the next wave. For example, these 2 points can either be two consecutive crests or two consecutive troughs in transverse waves, or they can be the distance between two consecutive compressions or rarefactions in longitudinal waves. The wavelength is also the length of one complete wave. It is denoted by the Greek letter lambda and is usually measured in meters, m. The wavelength can vary greatly. X-rays are very short, visible light is somewhat long, and radio waves are much longer. The frequency of a wave is the number of complete waves passing a fixed point in 1 second. Frequency is given the symbol F and is measured in units called hertz, Hz. Let's look at this wave, which is traveling from left to right. Can you count how many waves pass through point A in 1 second? Observe that in 1 second, exactly 3 waves pass through point A. Therefore, the frequency of this wave is 3 Hz. Lastly, let's discuss speed. The distance covered by a wave in a unit time is called its speed. Speed is measured in meter per second. Imagine seeing a flash of lightning and hearing the thunder of clouds. First, we will see the flash of lightning, and a few seconds later, we will hear thunder.
But why do we see lightning first?
This happens because both light and sound are waves that travel at different speeds. Light waves travel faster than sound waves. So, we see the light before we hear the sound. Sound waves are longitudinal waves, but the speed of the sound depends upon the type of the medium it passes through. Look at this table. Sound travels fastest in solids, then in liquids, and the slowest in air. Now that we have seen the 4 quantities, how are they related? Well, it turns out that the speed of waves is the product of the wavelength and the frequency. Therefore, Waves with longer wavelengths or higher frequencies will travel faster. Note that the speed of a wave does not depend on its amplitude. Today, we've learned.
Okay, students, hope you will understand all these terms, and your assignment is that you have to do example 10.3, 10.4, 5 and 6 and revise your topic and practice it. Okay, best of luck.